All right, welcome everybody. This is 7.4 on basic trigonometric equations. So what you need in this section is your basic algebra skills, know how to solve a basic algebraic equation, factoring, and the unit circle. That's all you need, okay? So our first example here says solve the equation sine of theta equals 1/2. Where is sine equal to 1/2? What's my reference angle if sine is equal to 1/2? 30. So it's a 30-degree angle in our first quadrant because sine is positive in our first, right? And in our second quadrant. Yeah, because sine is y over r, y over r. So this side here has to be square root of 3, correct? And look at what I just made. A 1, square root of 3, and 2. That means that this is 30 degrees, and this angle is 30 degrees, correct? Okay. So our theta is equal to 30 degrees or our theta is equal to 150 degrees. Right? Because this angle there is 150. Okay? We can also turn this into radian, right? If the question is asking us to put it in radian mode, radian form. 30 degrees is pi over 6. 150 degrees is 5 pi over 6. Okay? They're also going to ask you sometimes to provide all possible solutions. Okay? So once we get the answers or the solutions in one rotation or one revolution, right? We have to think about when that number occurs again. So in terms of sine, do you remember the graph of sine? Right? It goes up, comes back down, goes back up like that, right? And that's one period, correct? If we look at the graph of sine. It would go up, look something like that, right? And we can literally copy this. The next period of sine would be right there, right? That makes sense? We could paste it again, and my next period, I could just connect this and make a graph, make a sine graph, right? And it goes on forever, correct? So I want what they want, what your solution is your solution is essentially all possible solutions. Okay, not just in one rotation, not just in one period. Not just in one period, but all the possible ones. Okay, so since since sine has a period of, what's the period of sine? What's the size of one of these curves? Do we remember? 2 pi, right? Yeah. So you know that this will repeat every 2 pi units. Yeah. That makes sense? So if that's the case, to find all solutions, to find all solutions, we add the period. Okay. So the period of sine cosine is 2 pi. Period of tangent and cotangent is pi. Period of secant, or I should put cosecant, and secant is also 2 pi. Okay. Just for review. So I don't expect you to label or always add 2 pi to your answer to get it, right? To get all the, you're going to sit there forever. Literally, you're going to sit there forever if you're going to get the exact value. Okay. So going back to this one, if this is your answer and everybody understands why this is your answer in one revolution, right? If I'm going to label K as the number of revolutions. Okay. Meaning the number of times it goes around the circle. To find all solutions, to find all solutions, theta is going to equal pi over 6 plus 2 pi, because that's my period, k. That makes sense? Plus 2 pi k. And then the other one is going to be theta is going to equal 5 pi over 6 plus 2 pi k. Yeah. Do you guys understand the 2 pi k? Yeah. Okay. Questions on this? So this is the answer to find all solutions. All right. Yeah. Okay. Let's solve this equation. Cosine of theta equals negative rad 2 square root of 2 over 2. And list 8 specific solutions. Okay, so they want specific numbers, angle measures. Okay. So we've done this way too long for you guys to not realize negative square root of 2 over 2 is the same thing as negative 1 over square root of 2. Correct? the unrationalized version of square root of 2 over 2. Where is cosine? Where is cosine negative? What quadrants? 2 and 3. What angle measure is square root of 2 over 2? 45? Yes. If you didn't know that, you locate the two quadrants that cosine is negative, right? It's 2 and 3. I drew a random triangle in 2 and 3. Okay. I know cosine is x over r. So that's going to be 1 over square root of 2. This is negative because I'm in my negative x-axis. So negative 1 over square root of 2, right? The triangle itself, it leads me to say that my missing side is 1. Right? So it's 1 square root of 2. And by now, if you don't know that that's 45, I apologize. I did you a disservice. Yeah. Okay, everyone should know that, and it should kind of click in your head already. So here, our theta is going to equal 135. And our theta is going to equal 225. Right? In terms of radians, 135 is 3 pi over 4. And 225 is 5 pi over 4. Okay? So you want to list out 8 specific ones. I already have 2. Right? How am I going to get my third and my fourth one? Add 2 pi. So if I add 2 pi, so it's 3 pi over 4 plus 2 pi in terms of over 4, that's 8 pi over 4. Right? Yeah. So I can add 8 pi over 4, which is 11 pi over 4. Do the same thing with the 5 pi over 4 plus 8 pi over 4. That would be 13 pi over 4. How do I get my fifth one and my sixth one? I'm going to add 2 pi again. 11 pi over 4 plus 8 pi over 4. And then 13 pi over 4 plus 8 pi over 4. First one is what? 29 pi over 4. The second one is, oh no, not 29. 19 pi over 4. This is 21 pi over 4. Right? So I got my fifth and my sixth. I need 8. So I'm going to add another 2 pi. Right? So I'm going to add another 2 pi. Let me just write it out. 19 pi over 4 plus 8 pi over 4. And then 21 pi plus 8 pi all over 4. That is 27 pi over 4. This one is 29 pi over 4. That's my 8, right? And if you want to provide all the possible outcomes, that will be 3 pi over 4 plus 2 pi k. Make sense? Yeah. And we're adding 2 pi because that's my period. That's where it will always occur again. Okay? All we're doing is just adding 2 pi. I want to skip this one. Now we have these type of equations. Okay? This is when you need your basic algebra skills. Tangent squared theta minus 3 equals 0. First, let's solve for the tangent of theta. Okay? So what do I do first to solve for tangent of theta? Add 3 to both sides. When I add 3 to both sides, it's tangent squared theta equals 3. And then how do I get rid of the squared? Square root, square root. So this would be the tangent of theta equals plus or minus. Remember when you take the square root, it's plus or minus root 3. Correct? This one is always going to be over 1. Okay? So since tangent is positive or negative, yeah, it's going to be in all the quadrants. Because all the quadrants in all the quadrants, your tangent value is positive or negative, right? So literally, I'm going to draw random triangles in all 4 quadrants. Okay? What is that reference angle for all of them? 60? Yeah, it is. So all of them is 60 degrees or pi over 3. 60 degrees or pi over 3. The reason why it's 60 degrees is because tangent is y over x. So tangent is square root of 3 over 1, right? Y over x. And if you 1 square root of 3 and this side is 2, I just built a 30, 60, 90, right? Opposite the 30 is square root of 3. So that's, or opposite the square root of 3, I mean, is 60 degrees. So that's why that's 60. Okay. So again, here, this is square root of 3. Wait. This is 1, right? Negative 1. This is square root of 3, negative, square root of 3, negative. There are all 2s, right? So I want to just showcase that we do have a 30, 60, 90 triangle. Okay, so all of these are my answers. Okay, so theta is going to equal 60. Theta is going to equal, what is the second angle here? 120. What is my third quadrant? This is quadrant 1. This is quadrant 2. What's my third quadrant angle? 240. What is my fourth quadrant angle? 330. Okay. So those are my answers. So in terms of radians, 60 is pi over 3. 120 is 2 pi over 3. 420 or 240 is 4 pi over 3. 330 is 330? 300, right? That's 300. 300 is 5 pi over 3. Yeah. So all of these are my answers in one, right? But I want to find all. So what am I going to add? Plus, I hear two answers. Is it pi or is it 2 pi? It's pi because tangent has a period of pi. Okay, so I know every answer, every solution is going to pop back up every pi unit, right? So pi k, 2 pi over 3 plus pi k, 4 pi over 3 plus pi k, 5 pi over 3 plus pi k. Okay, cool. All right. Now you might be asking yourself, what is this? And it might be confusing, but it's not. Okay. Now we need our intermediate algebra skills. And if it looks confusing, class, and you have a trig function squared and you have a trig function, make x equal to that trig function. Okay? If you make x equal to that trig function and we plug it back in, 2 cosine squared, that's x squared. Correct? Minus 7 x. Instead of cosine, I want to plug in x. Plus 3 equals 0. Now, if I ask you to solve this black equation that we just wrote, 90% of this class, or even 99% of this class, would have no issue. Right? We just factor this out. Two x and x. This one has to be 3. This one has to be 1. So that's positive or negative and negative. Yeah, I'm not too sure how you guys learn how to factor, but I'm just factoring. Okay. So here, my next step would be 2x minus 1 equals 0. X minus 3 equals 0. So this one, x equals positive 1/2, and x equals positive 3. But since x equals cosine of theta, I'm going to plug this back in. So I know cosine of theta equals 1/2, and cosine of theta equals 3. Cool. Do you guys see anything wrong here? So the reason why cosine of theta cannot equal 3 is because the range or the domain of cosine or the range of cosine goes from -1 to 1. Yeah. Using our fundamentals of trig functions, cosine is going even back before x and r and y. It's adjacent over hypotenuse, correct? If it's adjacent over hypotenuse, is my adjacent side bigger or my hypotenuse going to be bigger? Which side is going to be bigger? Always. Hypotenuse. Your hypotenuse will always be bigger than your adjacent side, right? Yeah. So cosine will always go between -1 and 1. It'll never be greater than -1 or 1, right? Or less than -1. Does that make sense? Yeah. So that's why cosine of theta equals 3 does not work. Because it does not fit our range of what cosine can be. Okay. So cosine of 1/2, you guys can figure that out, right? Where it is. Moving on to our last one. I want to do this one before we finish our lesson. So solve the equation 5 sine of cosine, sine of theta, cosine of theta plus 4 cosine of theta equals 0. What can I do here? Hmm? Huh? Yeah, we're going to pull a cosine out. So cosine of theta, that's 5 sine of theta plus 4 equals 0, right? So cosine of theta equals 0 or 5 sine of theta plus 4 equals 0. Solve it. Okay. When you solve this one on the right, sine of theta equals -4. Sine of theta equals -4/5. You're going to end up with something like that, right? Okay. I do not want you to use your calculator just yet. So if you come out with an answer that looks like this, I will accept that answer. Just leave it as is. Deal with this one and try to figure out what theta is. Make sense? Yeah, so if you come out with a random number, you do need your calculator for it. I don't want you to use your calculator, okay, to figure it out. We'll do that later. But I want you guys to figure out where is cosine of theta equal to 0. And then give me that and find all the solutions. Okay? That's your lesson for today. Thank you very much and have a good one.